11th grade, chapter 6, circular and rotational motion. This chapter we will study two parts. First, the circular motion, secondly, rotational motion. First part, the circular motion. Circular motion, when an object revolves around a fixed axis at the fixed distance from it, and it has the radius, and it is showing the look like this. R, it's meaning radius from center point to the surface. It is showing in the figure, and in object when it is turning or it's moving, it has one speed, and between the 2 points it is taking the one way we are showing the S. During this motion, as the object covered a distance, we can show S is called arc in the circle path, circle way. The radius vector, in vector it's meaning it has the direction. Vector R which join the rotational axis, and the object sweeps out of the angle. Between the 2 points it's showing the one angle. This angle is expressed as we can finding the angle equals S over R. It's meaning S arc or between the two distance, and R is meaning radius. And for one complete revolution of the object, the angles sweep out by the radius vector. Radius vector in a degrees full angle 360 degrees, and in radian measuring 2 pi radians. Angle and radian, it is two kind of degrees. For degrees we are showing the full angle is 260 degrees, and full angle is about the radian 2 pi. When we are converting each other's radian to degrees, if you remember our equation, theta equals S over radians, and the surrounded the circle to full angle 2 pi r over r. Theta equals r, and r it will be simplified. Theta equals 2 pi radian. As 2 pi radian equals full angle, or 2 pi radian equals 360 angle. When we are dividing 1 radian, how much angle? 1 radian equals 360 angle over 2 pi. And if you remember, pi equals 22 over 7. This is approximately 3.14, and it will be continue. Since the angle is radian is defined as the ratio of the two length, arc length to radius, it has no dimension. The unit radian is carried only as the reminder that the angle are measuring in the radian and not in degrees. And you must memorize the 1 radian equals 57.3 angle. And the relation between the linear and the angular speed, since the average linear speed is the ratio of the linear displacement, if you carefully, it is using the displacement because of displacement a kind of vector quantity. The linear displacement to the change of the time, we can show average speed or average linear speed. It equals total displacement. We are showing the delta S over the change of the time. And if we are moving this circle, average speed we can show r multiply absolute value, the change of the theta over the change of the time, or we can show total or the change of the displacement equal radius multiply the change of the theta. And the average angular speed, we can show angular speed W, and average we can show R, V, G. Angular speed average is the ratio of the angular displacement to the change of the time, or we can find linear speed equals radius multiply angular speed. And all of them is angular speed, and average linear speed, the unit is same, meter per second. If you remember, it is SI unit system. When a particle rotates a cycle, then its linear speed equals the per meter of the cycle divided by the time of the full cycle. We are showing capital T, that is, or capital T, another meaning, period. And average linear speed equals 2 pi r. It is full displacement of the circle over t, or period. And we are writing the linear speed, if you remember, r multiply angular speed, look like this, equals 2 pi r over period. Two sides, it has the two r and r, it will be simplify, and angular speed equals 2 pi over period. And if you remember, before you learn how we can find it or how we can connect period to frequency. Frequency, we are showing the small f equals 1 over period. And angular speed, if you remember, W, or angular speed equals 2 pi multiply 1 over t. 1 over t equals frequency. We can write angular speed equals 2 pi multiply frequency. And the unit of period, second, or minutes. Unit of the frequency 1 over second, or special unit hertz. Example, a disk rotates with the angular velocity 5,400 rpm. RPM, its meaning revolution per unit. A angular frequency and the time period for one cycle. Another question, if the radius of the disk is 28 centimeters, what is the linear speed of the particles located on the per meter of the disk? Firstly, we convert the angular velocity from RPM, it's meaning revolution of the per unit, to revolution per second. If you remember, 1 minute equals 60 seconds. Angular speed or frequency equals 5400 RPM revolution over minute. Minute we can change 1 minute over 60 seconds. Minute and minute, it is simplified, equals 5400 RPM revolution over 60 seconds. This is equals 90 revolution per second. This revolution per second, it means frequency. Question asking angular frequency and the time per unit for 1 cycle. The question frequency equals 1 over temperature periods. This is equals, we know, and frequency 90 equals 1 over periods. And period we can find 1 over 90 seconds. Answer A. Answer B. Answer B. Calculate the linear of the particle. First, the angular speed. And it means we will find angular speed. If you remember our equation, angular speed equals 2 pi frequency. We find the frequency, angular speed equals 2 pi. In the equation it says pi, we can accept 3. Multiply 3, multiply frequency 90. Or we can not write anything about the pi. We can finding the with the pi equals 180 pi over second. Radian over second. And another equations we will find linear average speed. If you remember, linear speed equals angular speed multiply r. We find angular speed and it is giving the r, but r equals 28 centimeter. We must convert centimeter to meter. 28 centimeter equals 0.28 meter. Linear speed equals 180, and pi we can accept 3, but in the equation it is not giving the, we are accepting the pi equals 3. We will accept real number. Real number is 22 over 7 multiply 0.28 centimeter. Speed equals 180 multiply 22 over 7 multiply 0.28 equals 0.88. And last step, 180 multiply 0.88 equals 158.4 meter per second. Another questions. This question is not inside the books, but it will be practice. Firstly, we have the one washing machine. You know, in the washing machine, it is rotating inside the one piece of question. One drum of the washing machine rotated 1,000 to 100 times in a minute. Careful, it is giving the minute. We must change minute to second. Question, what is the period and the frequency of the drum? B, what is the angular speed of the drum? C, if the diameter of the drum is 40 centimeters, what is the tangential speed of the point on the drum? First, A, it is asking the frequency. Our equation is F equals 1 over period. And it is giving the turning, but it is giving the time. 1,000 to 100 over time, but it is giving the minute. We must change it to second. 1 minute equals 60 seconds over 60 seconds equals 21 over second, or hertz. And B, what is the angular speed of the drum? Our equations W equals 2 pi multiply frequency. And we find the frequency, and the equation say pi we can take 3 equals 2 multiply pi equals 3 multiply frequency. It is giving 20 centimeter. 20 per second equals 120 meter per second. And C, and last part, if the diameter of the drum 40 centimeter, we must convert 40 centimeter to meter. 40 centimeter equals 0.40 meter. And our equations, tangential speed equals radius multiply angular speed. We find the angular speed, and it is giving the radius. We can put only numbers. Equals R equals 0.40 multiply. We find the tangential speed. Tangential speed 120 meter per second equals 48 meter per second tangential speed.